Okay, here we have 9.3, which deals with polar and rectangular coordinates. So the objectives for this unit or section convert between polar and rectangular coordinates. So rectangular coordinates are given by x comma y. Polar coordinates are given by r comma theta. So you can convert from r theta to xy by using these equations. They're actually going to show up again later for a different purpose, namely for the cosine. It's x over r. If you divide both sides by r, you can do the same thing with y. Y over r. So you get those two equations. And so by using these two, you can convert from r theta to xy once again. So find the rectangular coordinates of each of these points. So this one I'm going to actually convert. So multiply by 180 divided by pi. That's 60 degrees. So for point P, x is going to equal the r value times the cosine of the angle. Y is going to equal the r value times the sine of the angle. So 5 cos 60 gives me 2.5. 5 sine 60 gives me 4.3. So point P lies at 2.5 comma 4.3. Do the same thing for Q. X is negative 13 cosine negative 70. Y equals negative 13 sine negative 70. So negative 13 cosine negative 70 gives you negative 4.4. Negative 13 sine negative 70 gives you 12.2. So point Q lies at negative 4.4, comma 12.2. Okay, so these equations are used to go the opposite direction. So given an xy value, find r theta. So here's r, square root of x squared plus y squared. Theta has two different versions depending on whether the x value is positive or negative. These rules should look kind of familiar. This is the same equation for magnitude, horizontal and vertical, and same thing for theta. Remember, arctangent is the same thing as the tan negative 1 key on your calculator. Alright, so example, find the polar coordinates of negative 8 comma negative 12. So the r value is the square root of negative 8 squared plus negative 12 squared. So that's 64 plus 144. The square root of that is 14.4. So for theta, I'm going to take the inverse tangent of negative 12 over negative 8. And that gives me 56.3 degrees. But x is less than 0, so I have to add 180 to my answer, which gives me 236.3 degrees. So the point R lies at 14.4 comma 236.3 degrees. That's how you'd write the answer. Okay. You can also convert equations from one to another. So in this case we have r equals 6 cos theta. So I need to get rid of this cosine theta. So I'm going to use that rule I had before, which gave me cosine of theta was x over r, and replace that here. So r is equal to 6 times x over r. So this is the same thing as r equals 6x over r. So we multiply both sides by r, which gives me this, r squared equals 6x. And from the previous page we had this equation, r equals the square root of x squared plus y squared. So that means that r squared, if I square this side, I'm just going to get x squared plus y squared. It's going to cancel the root out. So this equation becomes x squared plus y squared equals 6x. And then I'm going to move everything over, so x squared minus 6x plus y squared equals 0. So that's in rectangular form. So this one's going the other way, so convert this into polar form. So the first thing I need to do is FOIL. So this becomes x squared minus 3x plus 9 plus y squared equals 9. Remember, x minus 3 squared is x minus 3 times x minus 3. So this is x squared minus 6x plus 9 plus y squared equals 9. So the 9's can cancel out if I subtract the 9 over. I get x squared minus 6x plus y squared equals 0, which if you notice was actually the answer from above. So we're actually going to solve the same equation backwards. Alright, so I'm going to group my x squared and my y squared because I know that this is r squared, and x is equal to r times the cosine of theta. So you have this equation. So I want to solve for r here. No, actually you can't solve for r, because you have that r squared. So this would be your solution. And I guess technically you could do this, r squared equals 6r cos theta. And then cancel an r, divide both sides by r equals 6 cosine theta. And that would get you back to the same place, so r by itself on the left. So that's the solution for the last example.